2016 question 1. Elements X and Y form an ionic compound with the chemical formula X2Y. If the ion of X and the ion of Y have the same electronic arrangement, okay, they have the same electronic arrangement, which of the following may this compound be? Okay, so first off, my habit is if I see a chemical formula and the question is asking us about ions, so I tend to look for what were their original charges. Okay, so I'm going to go ahead and write down the chemical formula here. I'll use different colors to denote X and Y. And now my aim is to look for their charge. What was the charge on X and what was the charge on Y? So to do that, I need to use the method of the cross method technique. So originally, so I have the habit of writing it like this. So I'll write here X and whatever the number was plus the charge. Okay, this box here was the number, and the other one is Y and whatever the number is, and with the minus sign, the negative charge. Okay, and here, how did I get these values here? These values in orange. So of course I did cross method, right? So how does cross method work again? You take down whatever number was here and you bring it to the other side. You take down whatever number was on the red color X and you bring it to the other side. So here, first off, let's look at X. So the number here on the blue colored Y is nothing here, right? You don't see any number here. Why is that? Because it's just 1, as we know. So here, actually, originally, there's just number 1 on X. But we're not going to write it, as you know, because it does not look good. So the charge on X is just simply a plus charge. Okay? And how about on the Y? On the Y? As you can see, the number here below on X is 2. That means originally I had 2 here. And that is how it's brought about. So I'm going to go ahead and remove this arrow so it's easier for us to see. But now you know it does exist there. Okay? So now I figured out that the charge is X plus and the charge on Y is Y2 minus. So let me go ahead and look at my options here on the left. So lithium oxide. Now to make things simple, anything on the left here, as you will know, you'll notice that they're all positive charges because they're metals. So here I'm going to go ahead and write it down here so it's easier. So lithium, because it's in group 1, all of those elements in group 1, they'll have a 1 positive charge. Aluminium, on the other hand, you can look at the periodic table. You don't have to memorize it. But on the periodic table, aluminium is in group 3. So any element in group 3, all of them would have a 3 positive charge. Potassium is in group 1. It will have a 1 positive charge. Magnesium is in group 2. It would have a 2 plus charge, Mg2 plus. And we can do the same thing for the negative ions here, the anions. I'm going to use blue. Oxide, which is oxygen, is in group 6. So all elements in group 6, they'll have a 2 negative charge. So same thing for option B. Sulfide, it's also in group 6. Sulfur, which is the element. All of them, they have a 2 negative charge. Chloride, which is chlorine element. Chlorine gas is in group 7. All elements in group 7, they have a 1 negative charge. So that's the technique. Now let's see which of the following here match is with our X plus and Y2 minus. As you can see, for option A, lithium is Li plus and O2 minus. That's perfectly fine because it matches with it. But now look at option B. It's Al3 plus and O2 minus. That obviously does not match with our original chemical formula X plus Y2 minus. So you can immediately rule out B is wrong. And with this same logic, you can rule out D, which is also wrong. Okay, so we're done with our first part. Now, let's look at the second part. Now that I know it's only option A and C, now this is where originally where I highlighted this, the same electronic arrangement. So let's see, lithium and oxide here. So I'm going to take option A here and bring it down here. Lithium, as we know, it's having an electronic arrangement of 2 and 1 because it has 3 electrons. So lithium ion is when we remove this 1 electron, right? When we get rid of this 1 electron. So it just has an electronic arrangement of 2. And on the other hand, for oxygen, let's say for oxygen, let me use this color. For oxygen, it's having an electronic arrangement of 2, 6. But oxide ion, what's the meaning of having a 2 negative charge? It means I've added 2 electrons to it. I've added 2 electrons. So now it has an electronic arrangement of 2, 8. Now, do these two ions, as our question was saying, if the ion of X and Y have the same electronic arrangement, that would be our answer. Now, do these two ions, do they have the same electronic arrangement? Of course not. It's 2 and 2, 8. They do not have the same one. Now, using this same logic, you can now check for option C, whether it makes sense. So here, I'll go ahead and do it for you. So option C here, we have potassium. Potassium is 281. Is that 281? No, that's sodium. So it's 2881. So potassium ion would be, here, let me move it a bit down, 288, because I removed one of this electron. Okay. And on the other hand, sulfur originally is 286. Now to make it into sulfide ion, which is S2 minus, I'll add 2 electrons, same logic, and you'll notice that it's 288 as well. Now check whether these two ions are having the same arrangement, electronic arrangement, and you see that it perfectly aligns with our statement here. So here, electron arrangement aligned, ion charges also what X plus Y2 minus is. So our answer for this is C.